Hey guys, my name is Anthony. I'm a second year software engineering major at Cal State San Marcos, and in this video, I'm going to illustrate how badly tested programs and unprepared users can cause major problems. In software engineering, we learn that making a working program is good, but it's not good enough. And that's because we strive for three main things: maintainability, reusability, and productivity. In addition, our programs need to work for special cases, large amounts of data, and they need to be thoroughly tested for bugs. When these conditions aren't met, our programs will falter. So in today's world, where so much of our life is controlled by software like with smartphones, self-driving cars, and Zoom meetings, program errors can really cost lives. In the case of the Boeing 737 MAX, it can cost hundreds of lives. I'll be discussing what happened with the Boeing 737 MAX and what we can learn. If you didn't hear the news about it, in 2018 and 2019, two of these planes crashed. To compete with Airbus, another plane manufacturer, Boeing decided to make an incremental change to the Boeing 737 for fuel efficiency, and they called it the Boeing 737 MAX. To make the plane more fuel efficient, they had to move the engine to a different part of the plane, and this caused aerodynamic issues. So to compensate for this, they designed a software system called MCAS as a stopgap measure. MCAS, or the Maneuvering Characteristics Augmentation System, is designed to keep the plane's angle stable. Basically, without proper functioning of MCAS, the plane cannot fly. So in October of 2018, Lion Air Flight 610 nosedived into the Java Sea 13 minutes after takeoff, killing all 189 people. So a few months later, in March of 2019, Ethiopian Airlines Flight 302 nosedived into the Ethiopian soil 6 minutes after takeoff, killing all 157 passengers on board. It was determined that MCAS was at fault for both 737 MAX crashes. It turns out that in the training required for airplane pilots to fly the Boeing 737 MAX, Boeing did not tell pilots about the existence of MCAS. This is because Boeing wanted to cut costs by not providing additional training for the pilots. So as another cost-cutting measure, Boeing decided to only use one angle of attack sensor instead of two. So the angle of attack sensor is the main sensor that is used with MCAS, and it's very prone to damage from birds and other errors that just come from normal maintenance. Even still, Boeing decided it was okay to only have one sensor because pilots could override MCAS when it malfunctioned. But specifically, according to a 2018 Boeing memo, pilots only had 4 seconds to recognize an MCAS error and 10 seconds to correct it. This problem was worsened by the fact that the plane's operation manual didn't explain how MCAS worked at all, and didn't even tell pilots how much time they had to respond. So in both Boeing 737 MAX crashes, when the pilots realized the MCAS system was malfunctioning, it was too late to restabilize the plane. In addition, only 20% of 737 MAX planes even shipped with the MCAS malfunctioning warning system. Again, this is another example of Boeing just wanting to cut costs. So since both crashes, people have been asking, how did the FAA let this happen? In the creation of new airplanes, companies need to consult with the FAA or the Federal Aviation Administration. For Boeing, they viewed this safety step as another unnecessary and costly step. Boeing engineers assured FAA officials that they knew what they were doing. Because software and hardware systems have become so complicated, government experts like ones in the FAA have had trouble certifying these systems for themselves. So they mostly relied on Boeing engineers in the case of certifying that the Boeing 737 MAX is safe. In conclusion, the case of the Boeing 737 MAX is a good example of a failed developer-client relationship. The role of the developer is not just to design a working program, but to also detail it to the client. You can think of Boeing as a developer that didn't explain the function to the client being the pilot and the airline. It is the job of the programmers to fulfill this need. When this doesn't happen, disaster can strike, like what happened with the Boeing 737 MAX. To this day, Boeing blames the pilots for not properly overriding MCAS sensor failure. In reality, the pilots were not properly trained and prepared about the MCAS system. Thank you for listening.